Okay, so this is practice test for test 3. There are 33 questions. For the first problem, we need to find out either this relation represents a function or not. For a relation like this, we need to take a look on domain part. If there are two arrows going from the domain, then that is not a function. So, but in this case, just only one arrows are going from each of these inputs of the domain, so it's a function. But for the second one, as you can see from 8, there are two arrows are going, so that's why it's not a function. For ordered pair, you just try to pay attention on the inputs. If you see the repeated inputs, for example, the inputs are y, n, u, f, so no repetition, so that means it's a function. But for the second one, you do see 8, 8, they are repeated and they are giving us different output, so that means it's not a function. Okay, so let's look at the number 2. Number 2, we need to use the graph to find out either that is the graph of a function or not. So we need to use the vertical line test. If any vertical line crosses this graph more than 2 points, more than 1 point, then that graph is not a function. So clearly you can see that for the first graph, even y-axis is crossing more than 1 point, so it's not a function. For the second one, no vertical line will crosses this graph more than 1 point. Here the only thing you need to pay attention is here. This is open circle and this is closed circle, so that's they are not on the same vertical line because one is open. Open means there is nothing. Similarly here, and rest is just a separate, so this is the function. For this one, there are no 2 points on the same vertical line, so this is a function, yes. For this graph, if you draw a line passing through the, let's say -2 on x-axis, then it will crosses at more than 1 point, so this is not a function. But here there is no way we can find a vertical line crossing the 2 points on this graph, so this is the graph, this is the function. For the last one, look at here, these 2 points at 5, they are on the same vertical line, that's why it's not a function. So that's right. Let's go to number 3. Okay, we need to find out the value of the function at -3 for f and positive 4 at g of x. So just plug this -3 here. So -3 times -3 to the power cube. So I'm going to just use this PDF file for this problem. So this is number 3. F of -3 is equal to -3 times -3 to the power 3 minus 2. Just do the calculation. -3 times -3 times -3 is -27. This negative and this negative becomes positive. 3 times 27 is 3 times 7 is 21. 1. 3 times 2 is 6. 81 minus 2. 81 minus 2 is 79. So that's the value of the first function. The value of the second function at 4 is just put x equal to 4 in g of x, and that is -20, -3, that is -23. So for the first part it's 79. For the second part this is -23, and that's correct. Let's go to the next problem. You have to find out the value of h at 4 of y, so just replace this x by 4 of y. So let me go to the next problem, which is problem 4. H of x is x squared minus 5. H of 4 times y, so you just replace this x by 4 times y. So that is 4 times 4 is 16, y squared minus 5. So So this is what we're going to put here, 16y square minus 5. Check it. So that's number 4. Let's go to number 5. So suppose that the relation T is defined as follows. So the relation is given as an order pair, and now we need to find out the domain and range. Domain means the x values, range means the y values. So here you can see that for the x values, uh, we need to use the set notation. So let's use this one: 8, -9, 6 and 5. 8 comma -9 comma 6 comma and 5. For the range, we just have to collect the y values, which is 8 comma 5 comma -1 comma 0. So the y values 8, 5, -1, 0. So that's the domain and range. Let's go to problem 6. We have given f of x and g of x. We need to find out the domain and of these two functions. As you can see that domain for this rational function comes from the restriction comes from the denominator. We need to find out the value of x for which this denominator would be 0. But as you can see that for the first function, x square is either 0 or positive. So x square plus 64 cannot be 0. No way. So that means the function for the domain for the first function has no restriction. That means by using interval notation, we have to use negative infinity to positive infinity, because there is no restriction for the first function. But for the second function, as you can see that there are two values for which this denominator would be 0. They are x equal to 1 and x equal to -1. These are the two values that makes the denominator part 0. We don't want positive 1 and -1 in the domain, so we need to remove those -1 and positive 1. For that, we can just, to see that, we can just equate this denominator with 0. So let me show you how to do that. Number 6. For the first function, we have to equate x squared plus 64 equals 0 and solve it, but there is no solution. So that means there is no restriction. So the domain is all the real number. For the second part, for the function of g of x, we need to solve x squared minus 1 equals 0, and that gives us two values, x equal to positive 1 and -1, for which this expression would be 0. So the domain of this g of x would be all the numbers except 1 and -1. So real number, all the real number from negative infinity to positive infinity except -1 and positive 1. We need to write it down using the interval notation. So you have to use parenthesis -1, negative infinity up to -1, parenthesis, union, anything after -1 to positive 1, union, anything after positive 1 to positive infinity. This is how you have to write. So the domain of z here, you can see this is negative infinity to -1, union, again -1 to positive 1, union, again positive 1 to positive infinity. Check the solution, and that's right. Let's go to number 7. We need to find out the domain of this radical function. As you can see that if you have even radical, the expression you inside the even radical should be always non-negative. So to find out the domain of this kind of function, remember this should be even radical. Here it's a square root. Square root means power. There would be 2 here, so but we don't write 2 here. So for this kind of function, 7, number 7, this is number 7. To find out the domain, this is the restriction we have to solve. This 8 minus x, which is inside this radical sign, supposed to be greater or equal to 0. If you solve for x, just add x both sides. It gives you 8 is greater or equal to x. Another way of saying the same thing is x is less or equal to 8. So the domain would be any real number less than or equal to 8. So anything on this side. So if you have to use the interval notation, that would be from negative infinity to positive 8, including positive 8. So you must use what is that? This one actually. No. Let's this one. So negative infinity to positive 8. So that's the right answer. Let's go to the next problem. Next problem. To find out the domain one more time, the expression inside this radical sign should be non-negative, and the expression on the denominator should be non-zero. So we need to consider the both of the restriction here. So if you go to problem 8, you can see that the expression inside this radical sign should be non-negative, and the expression on the denominator part should be not 0. So we need to consider 10 plus x should be greater or equal to 0, and also negative 2 plus 2x is not equal to 0. So let's solve these two things and let's see what happens. Okay, so if we try to solve this one, this gives us x is less or equal to negative 10. Just subtract 10 from both sides. So x would be less or equal to negative 10. If we try to solve this one, x is equal to 1. So the one restriction is x should be less or equal to negative 10, but x cannot be equal to 1. So that's good. So x cannot, if you just choose, and both of the situations should be satisfied. So if you choose x is less or equal to negative 10, then that would be fine. N means intersection. X cannot be equal to 1, and x would be less or equal to negative 10. So that means the intersection of both of them would be x is less or equal to negative 10. Okay, so the intersection of these two, x is less or equal to negative 10, so this part, and this is anything except positive 1. So anything except positive 1. So let's see, so you can see that anything here and here. So what is the intersection of this part and this red part? The intersection is anything less or equal to negative 10. So the answer for this problem would be from negative infinity to negative 10, including negative 10. So that's the intersection. So anything from negative infinity to, sorry, we need the bracket, negative 10. Check it. Wow, what was the problem? So let's see one more time what I did wrong here. So let's go here, negative infinity to, did I do something wrong here while solving it? 10 plus x would be greater or equal to 0. That means if I just subtract, okay, x would be greater or equal to negative 10. Sorry about that. This would be greater or equal to negative 10. So instead of doing, okay, let me go over here. Instead of graphing less than negative 10, it should be greater than negative 10. So my bad. So you have to, this part should be greater than negative 10, greater than negative 10. So it's my bad. While solving the inequality, you have to pay attention here. So let's go back one more time. It should be greater or equal to negative 10. So if I try to plot the graph here, this is negative 10, and greater and equal to negative 10 is this part. So we are trying to find out the intersection of this and this. So intersection should be negative 10 should be somewhere here. So the intersection would be, the common part would be from negative 10. So from negative 10 to 1, and we cannot include 1 because 1 is not here, and then union from 1 to positive infinity. This is the intersection between these two. My bad. Okay, so let's go back and put it here. Negative 10 to negative 10, including negative 10. So negative 10 to 1 union 1 1 to positive infinity. So recheck, and that's right. So while solving the inequality or anything, you have to pay attention. I did mistake here first time, and I fixed it. Okay, so that's problem 8. So now let's go to problem 9. Problem 9. What is problem 9? For each of the following equations, determine whether y is a function of x. You just have to check the power of y. If the power of y is even, then that's not a function of x. Here the y power is 1, so this is the function of x for sure. The y is 1, function of x. Y has power 2, so not a function. Y has power 2, not a function. Go to next problem, problem 10. You have to find out this expression. This is called difference quotient. So I'm going to use my notebook here. That's problem 10. Our function is given, f of x is 4x squared plus 5. My pen is not working, so let me just fix it. So first of all, you need to find the value of the function at x plus h, and you need to simplify that, and then you need to subtract f of x from fx plus h. You have to simplify that too, and then after that you have to subtract f of x from f of x plus h. So just replace this x by x plus h. To show that replacement, I'm going to use different color here. Let me use blue color. So I'm going to replace this x by x plus h. So here it would be 4 times x plus h squared plus 5. Now since I need to subtract f of x from here, so I'm going to simplify this part here. So make sure that this x plus h squared becomes x squared plus 2xh plus h squared, and there is a 5, and just distribute this 4. So it's a 4x squared plus 8xh plus 4h squared plus 5. 5 is separate. Now just subtract f of x from fx plus h. So I'm going to just subtract f of x from fx plus h and also divide that expression by h. So that means just plug the value of fx plus h, which is 4x squared plus 8xh plus 4h squared plus 5 minus, so now I'm going to use red color here to show the difference here. minus f of x, because there is a minus sign. So while plugging the value of f of x, look at the value of f of x, which is 4x squared plus 5. You have to apply the minus, so it would be minus 4x squared minus 5, minus 4x squared minus 5 over h. So if you try to simplify on the top, this 4x squared and this 4x squared will be cancelled out, this 5 and this 5 will be cancelled out. The only thing on the top would be 8xh plus 4h squared. So factor out h. Always try to factor out h. That's the whole point, because we would like to cancel this h on the denominator. So the leftover would be 8x plus 4h. That's the expression we are looking for. Here it is 8x plus 4h. 8x plus, what is that? Let's go back. 4h. 4h. Check your answer. And that's the correct answer. That's problem 10. Let's go to problem 11. The graph of function is given. Find out the value of the function at 3. So just check the graph and go to when x is 3 and find out the y. Y is -2. That is the value of the function. So I'm just going to type -2. And now the next question is find out the value of x for which the function is 2. So just check the graph where the graph has y value 2. So 2 means positive 2. So this is the graph where the graph has y value 2, and that is at x equal to 1. So the answer for the first one, the second one would be when x equal to 1, the value of the function would be 2. Correct. Let's go to next problem. So that is problem 12. The entire graph of the function h is given here. Write the domain and the range of h. For the domain, you just look at the x values for this graph. So you can see that x is going from -4 up to -1, including -1 but not including -4. And then there is a gapping from -1 to +2. There is nothing, no graph. So the next thing is we'll start from +2 and go up to +4. So the domain would be -4 to -2, including -2, union, that's not the end, so union from including +2 to +4. So +2 to +4. So remember, the domain comes from the x value of the graph, and range is from what value, the y value, to what y value. So you can see that this is the lowest one, which is -3 up to +5, not including -3. So you have to use the parenthesis -3 comma +5 for the bracket for the +5. So that's problem 12. Check the answer. Partially correct, so there is something wrong here. So what is the wrong? Let me find out. For the domain is from -4 up to -1. I'm sorry about that, I missed that part. Here is the negative, here supposed to be -1, but I wrote -2, so that's my mistake. So that should be -1, and from +2 to +4, and the range is from -3 up to +5. So let's recheck it, and now it should be correct. Okay, so as you can see that I'm also doing some mistake, because I'm not following the information correctly. Sometimes I'm just misreading it, so it happens. It happens. So just be careful when you take the test. Be careful to read the questions and given information and your answer twice. Okay, so let's go to next problem, problem 13. So we need to use the graph and we need to answer this question. Is f3 negative? So that means the value of the function when x is 3. And as you can see that the value of the function at 3 is negative. Yes. For which value of x the function is 0? So as you can see that the graph on x-axis, this point at -3, 0 and +2, the value of the function is 0. Look at the graph here. At -3 the function is 0, at 0 the function is 0, at 2 the function is 0. So you are trying to separate the answer using the comma. So at -3, comma, 0, comma, +2. And for which value of x the function is negative? As you can see that from -3 up to -1 the function is negative. From +2 to +5 the function is again negative. We need to use the interval notation. So as you can see that parentheses from -3 comma to 0 parentheses, we have to use the parentheses because at -3 and 0 the values are 0, and to the left of -3 it's negative up to 0, and there is a union from 2, again parentheses, 2 comma 5 up to 5 it's negative parentheses. So in this interval the function value is negative. Check. Partially correct. One more time, I did mistake here. I don't know what I did, so let me go back and check it. Is f3 negative? F3 is negative, yes. For which value of x the function is 0? If there is more than one value, separate them with comma. So at -3 it's 0, at 0 it's 0, and at +2, I am so sorry here, I did at 3 but it's supposed to be 2. Okay, so remember one more time. Oh, okay, again it's not right, so I also have to check this thing from -3 to 0, and from 2 to 5 the function is negative. From -3 to 0, not including -3 and 0, the function is negative. And again from 2, not including 2, to 5, including 5. Sorry, I did not include the 5. Sorry, that's my bad. One more time. Look at here. Look at this graph here. At 5, what I did is what mistake I did is here at -3 it was 0, so I did not include that. At 0 it was 0, that's why I did not include that. I used the parenthesis. At 2 it was 0, so I did not include that. So I just followed that pattern, and also I did not include 5, but I should also include 5 because at 5 the value of the function is -1. So here, I'm supposed to use the bracket. So remember, double check your answer. Okay, so now it's correct. For me, I'm just doing the review, and so that it doesn't matter, but for you it's very huge thing. So please double check your answer. Okay, let's go to next problem. Problem 14. Graph the function. To plot the graph, there are different ways. You can use the slope and intercept form. So as you can see that the intercept is -7, that means the y-intercept is -7. -7 is here, -7 is here, and then after that the slope is 3, so go 3 unit up, 1 2 3, -7, and then 1 unit right, because the slope is 3 over 1, so rise over run. So -7, 0, -7 is your y-intercept, and because the slope is 3, so it is 1 unit, 2 unit, and 3 unit up, 3 over 1, so 1 unit right. So that's the one way of plotting the graph, slope intercept form. Another way is find out the points. Put x equal to 0, it gives you y equal -7, so 0, -7 is 1 point. put x equal to something else. For example, x equal, I'm trying to use some solid point. Let's say x equal 1. Then the y would be 3 times 1 minus 7, which is negative 4. So that's how you can uh, find the find the 2 points. Let's check that. Okay, correct. Let's go to the next problem, problem 15. Problem 15, plot the graph the equation. Remember, this is an absolute value function, so we have to start with the absolute value function, and we have to shift that absolute value 5 unit to the left, and then after that there is a negative sign, so we have to reflect it, and then after that we have to stretch it by 3 unit, and then finally shift the graph 4 unit down. That's how we have to do. So there are steps you need to follow for this graph for problem 15. Problem 15, you take the graph of absolute value and you go to graph of absolute value of x plus 5, and then you go to the reflection, and then or maybe that's up to you, reflection or the stretching, and then after that you just go to stretching, so you have to multiply this by 3, so this is negative 3 times x plus 5, and then finally you have to shift it vertically down, negative 3 x plus 5 minus 4. So what you can do is, to make it easier, just start with the graph of absolute value of x, take some points from absolute value of x and follow the pattern. Okay, so let's say the point on the absolute value of x is xy. So let me just use different color here. The point on the absolute value of x is xy. So if you go from xy to this is horizontal shift to the left, so you need to subtract 5 from the x coordinate, and from here to there means it's a reflection about, this is the reflection about this is negative f of x, so that means it's a reflection about x-axis, so that means you have to make the negative y. When you go from here to here, it becomes x minus 5 negative y. You see that I'm using the same x coordinate, but I'm just reflecting the y coordinate, and from here to there you are just multiplying this y coordinate by 3, so eventually it becomes x minus 5 minus 3 times y. And now finally, to go from here to here, you are just taking the graph 4 unit down, so that means the vertical shift down, so you are subtracting 4 from the y coordinate, so this is the y coordinate negative 3y, you are just subtracting 4 from there. So if you start a point, if you just pick a point from the absolute value of xy, eventually you have to do this calculation to find the point on your new graph. So I'm going to do that here. Let's say, so remember, xy will be x minus 5 comma negative 3 times y negative 4, negative 3 times y negative 4. So xy from the absolute value of x is going to be x minus 5 comma negative 3 times y minus 4 for negative 3 absolute value of x plus 5 minus 4. That's how you go from graph from here to there. So let's plot the graph of absolute value of x. As we know that absolute value of x is very standard graph, just pick some points. You need to pick 0 0 for sure, because that's the division from left to right side, and you can pick another point here 1 1, or maybe another point here negative 1 and 1. And since you are going from you are going from xy to x minus 5 comma negative 3y minus 4. Let's use different color. So just plug for 0 0, just plug x equal to 0 here and y equal to 0 here. It will be negative 5 negative 4. So this 0 0 becomes negative 5 and negative 4. So 1 2 3 4 5, 1 2 3 4. So this 0 0 becomes negative 5 negative 4. I got this point by plugging x equal to 0 here and y equal to 0 here and simplification. Now this negative 1 comma 1 becomes, just plug x equal to negative 1, so it becomes negative 6. The y is 1, so negative 7. So negative 6, 5, negative 6 and negative 7. So what is negative 7? Negative 7 would be, this is 4 5 6 7. So negative 7 would be here. Okay, negative 4. Similarly, now this 1 1, just plug x equal to 1, so that would be negative 4. Okay, negative 4 means 1 2 3 4, and y equal to 1 again, so that would be negative 7. So negative 4 negative 7. So here is the negative 4 negative 7. But remember, to join this point you have to just copy the nature of this absolute value. So you just have to copy the nature of the absolute value like this. So because of this reflection it will flip downward, and because of this stretching it will go more stretched downward. So I'm going to just use these 3 points, negative 5 negative 4 negative what is that, what is this second point, negative 1 2 3 4 5, negative 6 negative 6 negative 7, and this point is negative 4 negative 7. So I'm going to just plot these 3 points. So negative 5, okay, where is that, here you go, negative 5. So let's go back here, negative 5 negative 4, negative 5 negative 4. Is that right? That's negative 5 negative 4. And another point is negative 4 negative 7. Okay, let me cross it, negative 5 negative 4 negative 5 negative 4. And then second point is as you can see, that's negative 4 negative 7, negative 4 negative 7. What is that, 7, negative 4 negative, that's wrong, that's wrong. Okay, let me make it bigger. So the first point is negative 5 negative 4, negative 5 negative 4. The second point is negative 4 negative 7. Okay, and now again the first point is negative 5 negative 4, and then second point on the other side is negative 5 and negative 7, negative 6 and negative 7, negative 6 and negative 7. Is that right? Here you go. Okay, so that's the graph of absolute value, negative 3 times absolute value of x plus 5 negative 4. And check the answer, that's correct. Okay, we just need 3 points to plot the graph for absolute value function. Let's go to the next problem. Okay, so next problem is, this is you have to plot the graph of parabola, but you have to use the transformation x minus 1 is square, which is take the parabola and shift it to the right 1 unit and then shift it to 3 unit up. So we can use the same trick here the way we did previous problems. So let me just add some paper here, pages here, sorry, I said paper but I don't have actual physical paper here. So This is next problem. We want to go from x square to x minus 1 square plus 3. So this is problem 16. Problem 16. Our job is to plot the graph of y, which is x minus 1 square plus 3. So we can go from x square to x minus 1 square to x minus 1 square plus 3. So the way we did last problem, I'm going to use the same trick here. My point from xy, if I go from this step to this step, it becomes x plus 1y. Remember, this x minus y square means it's shifting to the right, so changing the x coordinate means you have to add 1. And then finally you have to shift the y coordinate 3 up, so you have to add 3 to the y coordinate. So any point from the parabola becomes x plus 1 comma y plus 3. So start with your graph of parabola, which is this one. Take some points. You must take 0 0, take 1 1, and take negative 1 1. This point, now we change these points, 3 points, using this formula. Put x equal to the value of the point for the x here and y here. So now you can do that. This negative 1 and 1 becomes, if you put negative 1 here, it becomes 0 4. For x 0 and y 0, if you put here, it will be 1 3. For 1 and 1, it will be 2 4. So these are the 3 points we're going to use for the parabola, which is 1 3 0 4 and 2 4. So this is the parabola. Okay, so it says make sure to plot the 5 points. So we need to find out the 5 points. Okay, so 3 points are there, so you can also take 3 more points. Take at 2 the value would be 4, at negative 2 the value would be 4. So if you use the same formula here, this negative 2 4 becomes, just use x equal to negative 2, which is negative 1 4 gives you 7. Positive 2 4 becomes 3 and 7. So these are the 5 points we're going to use now. 0 4 0 4. Okay, what is that? Make sure to plot 5 points before graphing the function. Okay, so let me plot the 5 points. The 1 point is 0 0 comma 4. Okay, that's the first point. Plot point again. Okay, there is a double comma, so let's just remove the 1 comma. Plot point. So another point is, as you can see, 0 4 1 3 1 1 3. Plot point. Another point is 2 4 2 and 4. Plot point. Another point is negative 1 7 and 3 and 7. Negative 1 comma 7. Plot point. And 3 and again 7. Plot point. Okay, we plotted the 5 points. Now we're going to use this one. So that's how we get the graph. Check it. The answer is correct. We're just shifting the graph x squared, but you need to follow the, this is first time I'm doing graphing on this Alex thing. So to plot the graph using the Alex tool, you have to use 5 points. So just do that. Okay, that's problem 16. Continue. Let's go to problem okay, I'm going to problem 17 now. So problem 17, you have to plot the graph of, okay, so what is that? Okay, so for this problem, it's square root function. So you are taking the square root of x, you are shifting this to the right 1 unit and multiplying the y coordinate by 3. So very exactly same, but let me just, this is problem 17. Problem 17, you are going from square root of x to square root of x minus 1, and from here it's a 3 times square root of x minus 1. So if you start with the xy point, this is the right shift 1 unit, so x plus 1 y. This is the multiplication of the y coordinate of previous function, so it's x plus 1 3 times y. So if you pick any 5 points from the square root of x, so this is the square root of x, pick 5 points, 0 0 1 1 0 2 9 3 and then 16 4. These are the easy points to find, that's why I use these 5 points, but if you want you can use something else. Now just add 1 to each of these x coordinate and then multiply the y coordinate by 3. So this 0 0 becomes 1 3. So sorry, 0 0 becomes, add 1 which is 1 and multiply the y coordinate by 3, so 0 times 3 is 0. So 1 0. Okay, this 1 1 becomes 2 3. This 4 2 becomes 5 6. So just do that, you know, this 0 0 becomes 1 0 and 2 3 and 5 6. I'm just multiplying each of this y coordinate by 3 and adding each of this x coordinate 1 to each of these x coordinates. So 10 9 17 and then 12. So I'm going to plot these 5 points here. So let's see, 1 0 2 3 1 0, plot it, 2 3, plot it, and then after that 5 6, plot it. After that what is another point, 5 6 10 9 and 17 12. 10 9 and 17 12. Okay, this point is out of bounds, so pick something else then. If it's out of bounds, then we need to always keep in mind we have to think about this restriction we have given here. So let's pick you know let's say we picked 16, so let's pick something else from here. Let's say what happens to on the, you know, for this one, let's say 5. If I pick 5 for the square root function, the value would be square root of 5, so that would be now 6 and then 3 times the square root of 5. So I have to use 6 comma 3 times the square root of 5. Let's see if I can do that. 6 3 times the square root of 5. And no, we cannot, this is not okay. 5 becomes 6, 3 times the square root of 5. 3 times square root of 5, square root of 5. Okay, so we plotted 1 2 3 4 5 points. We're good. Just use this one, check it, and you see that's right. Let's go to next problem, problem 18. Problem 18, it says, you know, plot the graph of cube root of function and shift it 2 unit down. So you have the cube root function and shift it 2 unit down. So make sure that you know the, you know, cube root function. The cube root function, you know, Okay, let me. Okay, so we know the graph of cube root function. This is the basic or standard graph. So this is the cube root function. Find out 5 points. So 0 0 is there, 1 1 is there, negative 1 is there. So another point is make sure that while shifting it, you should be able to find the points which is inside this frame. So we also have to consider that restriction. So cube root function, so that means let's say 8 gives you 2, -8 gives you -2. Okay, so let's shift these points. How many units? 2 units down. So you just have to change the y coordinate. So at 8 the y coordinate would be 0. At 1 the y coordinate would be -2. So something like that. Let's plot those points. 8 8 8 the y coordinate would be 0. Plot it. At -8 the y coordinate would be -4, because if you go back here at -8 the y coordinate at this point is -2, but you have to shift it 2 units down further, so it will be -4. This -1 becomes -3, -1, the y coordinate becomes -3 because you are shifting it 2 units down. 0 will go down 2 units down, so that means -2. So how many points? We need one more point, so 1 1 becomes 1 -1. 1 2 units down means it's a -1. So plot it. Now use this one and check it. So finding the points and just plotting 5 points here and using this shape would help us to plot the graph. Let's go to next problem, problem 19. So this is you need to find out what function is this. This is parabola quadratic function x square. This is a reciprocal function 1 over x. This is identity function which is x, and this is a square root function, and just check it. Correct. Let's go to next problem. For functions are given, you need to find out either those functions are even or odd. So here you can see that, keep in mind the even function means it's symmetric with respect to y-axis. Odd function means it's symmetric with respect to origin. This is symmetric with respect to y-axis. This is neither, because it's not symmetric with respect to y-axis or the origin. This function is odd function because you can see that the power is odd if you replace x by -x. So that will be, the function will be is equal to negative of g of x. This function, you need to check it. You have to do the math here. So that's problem 20. To find out either the function is even or odd, h of x is given, which is -6x to the power 4 plus 7x squared. I'm going to replace x by -x. Because of this even power, it's going to be again positive. So you can see that eventually it will be 6 times x to the power 4 plus 7 times x squared. Eventually this is the same original function, and that's the definition of being even function. So this is even function. You can do the exactly same thing for this g of x, but it was so trivial, that's why I did not do that, but you have to do it to check. So now if you just submit it, it's the correct answer. Let's go to the next problem, problem 21. You need to find out either this is symmetric with respect to x-axis, y-axis, origin, or none of this. As you can see that this is symmetric with respect to x-axis. This is symmetric with respect to y-axis. And also, if you can see, is this symmetric with respect to origin? So to find out that thing, pick any points. For example, let's say this point, which is um, negative 1.5 and then 3. So negative 1.5 and negative 3 should be there. Okay, so for example, let's pick this one, which is 1 and 4 point something. 1 and negative 4 points should be there. So this is symmetric with respect to origin as well. So y-axis, uh, x-axis, origin, all of them. This graph is symmetric with respect to origin only. For any point, you are going to find the negative of that points, meaning if you pick x and y, there will be negative x and negative y. So origin. So let's check it. And what is that? It's taking time. Check it. So this is correct. Let's go to the next problem. You need to find out the composition W composite U at -4. So first of all, find this composition in both order and find the value of the composition at -4. So finding the composition is, so this is problem, I think it's problem 22. So let's find out the composition of WU. So that means find out the value of W at U. So which is, for the function W, just replace x by U. So that means the U is actually -2. Okay, U is actually negative x, -1 plus 2. Now you just distribute -2, that is 2 times x, +2, +2. Finally it is 2x plus 4. So for finding the value of this composition at -4, finally you have to replace x by -4 here. So that will be -8 +4, which is -4. So the answer for the first one is -4. The answer for the second one, you have to do the same thing, but you have to find the composition of other way. Okay, so that means let's find the composition of U composite W. So that means you have to use the U function, replace x by W there, and finally plug the value of W, which is -2x squared +2, and you have to distribute this negative, so that will be 2x squared -2 -1. This is 2x squared -3, and then U composite of W at -4, just plug the value of x -4, so that is 2 times 16 minus 3. 16 times 2 is 32 minus 3 is 29. So for the second part, this is 29. Partially correct. So W composition of U at -4 is not right. So let me go back and check it. What's going here? W composite U. So this is the problem. So what is that? I plug U in W, which is -2 U square plus 2, and I put the value of, okay, I forgot to square this thing. You see here, there is a square and I forgot to put the square here. So it's supposed to be square. After square, it should be, let me just clean it. Where is that? Just clean this thing. After cleaning, I'm going to find it again. Okay, so after cleaning, let's see what happens here. Okay, so if I square this thing here, it will give me x squared plus 2x plus 1. Square of the negative would be positive, that's why. and then after that it is negative 2x squared, negative 4x, negative 2 plus 2. This 2 and this 2 cancel out, so the only leftover would be this one. So I have to put negative 4 here, so that will give me negative 2 times 16, and this is positive 16. So negative 2 times 16 is negative 32, plus 16 is negative 16. So the answer for the first part should be negative 16. Okay, we check it, and now this is right. Let's go to next problem, problem 23. uh, Problem 23, you have to find out the composition of this two function by doing exactly the same thing, composition. So f composite g, this is problem 23. F composite g x, this is plug the value of g of x in f of x. So this is 2 times g of x plus 10, and finally plug the value of g of x, which is x minus 3. So if you do that, it will give you 2x minus 6 plus 10, and so if you just simplify this, that will be 2x plus 4. Let me just add some extra pages here. So that is 2x plus 4. So for finding the domain of this function, we need to find the domain of g of x, and then domain of this final function, and the domain of this composition would be the intersection of both. Okay, so that's the rule. So domain of inner function g of x is all real number, and now domain of this thing is can be found by solving this inequality, because the things inside the radical sign should be non-negative if it's the radical is even. So if you try to solve it, so x would be greater or equal to negative 2. This is the domain from here, and we know the domain of g of x is all real number. So the domain of this composition function would be intersection of these two, which is basically this one. So the answer for the first part is square root of 2x plus 4, square root of 2x plus 4, 2x plus 4, and then domain as you can see, it's greater than negative 2 to infinity, including negative 2. Let's check it, and that's correct. That's 23. Let's go to 24, and here we have graph of, using the graph of x squared, we need to plot the graph of half of x squared. So let's do that. Graph of half of x squared. Okay, so first of all, take some points from x squared, and then you just have to, let me just show you here. Take here is x squared, and you are multiplying the y coordinate by half. That means it's a shrinking vertically, so we can use this one. This 0 0 becomes 0 0 for sure, and this 1 1 becomes half, so it go to the half. No, it's a vertical shrinking and stretching, so I will go again here, so vertical becomes half. Okay, so this this 4 becomes 2. Yeah, that's right. That's right. That's completely right. Okay, so this is for vertical stretching and compression. This is for horizontal stretching and compression. Let's go to the next problem. Next problem is okay. The graph of y equal x squared is shown. Grid part A and B. Use the transformation to get the graph of this. Oh, there is another part. Negative 2x squared. So this is if you just simplify this, this is 4 times x squared. So again, it's a vertical stretching. So this one becomes 4. You just have to find out one point, and you can see all other points coming through. So that's why we are done for this part. Let's go to problem 25. You have given x squared. This is exactly the same problem we already did. This is shifting 2 unit to the left and 3 unit down. So shifting 2 unit left and 3 unit down. 2 unit left and 3 unit down. Yes, this 0 0 go to the 2 unit left and 3 unit down. Check. Wow, incorrect. Why is that? Shifting 2 unit left and 3 unit down. What I did here, 0 0 go to -2 and -3. When x is -2, that is +3. Sorry, it's not down, it's up. +3 means vertical shift up, my bad. So you take this graph, 0 0 go to -2 and +3. It goes up because there is a +3, my bad. Okay, so recheck, and here we go. Just follow the rules: vertical shift, horizontal shift, stretching. So this is the graph of f of x is given here. Translate it to the graph of fx plus 2. That means it's a left shift 2 unit. So you take this graph and shift it 2 unit to the left, because you're adding to the input, so that means you have to shift it to the left. So this 2 1 becomes 2 0, because if you shift this 2 1 to the left, 2 unit left, it becomes 2 1. Sorry, 0 0 0 1. So you are shifting this graph, the original graph, 2 unit to the left. And here you are adding 4 to the function, so that means you are shifting this graph 4 unit up. 4 units. So this 0 0 becomes 0 4. Now let's check. Correct. Let's go to the next problem, 27, and do exactly the same thing. F of x is given, f of negative x is needed. So that means it's a reflection, x becomes negative, so that means it's reflection with respect to y-axis. Very same graph, but reflection. So this 4 2 becomes negative 4 2. So let's plot that. Negative 4 2, negative 4 2, negative 4 2. And another point, this 6 5 becomes negative 6 5, negative 6 and 5. What is the 5? Here is the 5. Okay, so this is the reflection of this point, this is the reflection of this point. This negative 4 6 becomes positive 4 6. So positive 4 6, from here to positive 4 6. Okay, and another point is same point like this. So this is the mirror image of this graph, because we are replacing x by negative x, and here we are replacing y by negative y. So that means this graph is going, this is the reflection with respect to x-axis. So as you can see that you just have to plot the graph of a line. So just take 2 points. The one point is -4 positive -5 becomes -4 positive 5. So -4 positive 5. Another point, this point is 4 negative 7 becomes 4 positive 7. 4 positive 7. What is positive 7? Here, here. 4 positive 7. So do you see the mirror image of this graph with respect to x-axis? So just check it. Okay, your answer is incorrect for the first one. Why is that? Did I do something wrong? The mirror image of this is this. That's right. This is -4 6 and this is +4 6. Mirror image of 4 2 is -4 2. That is also right. What is the problem here? Did I do something wrong here? Okay, so let's try it again. This is -4. Let me just draw the line. -4 6 becomes +4 6, +4 6. Okay, and then another point is this 7. Oh, this is 7. Oh, that was my mistake. 7 and 5 becomes -7 and 5. -7 and 5. Okay, so that was the mistake. Okay, this is 7 and 7, and as you can see that this is 7 and 5, so this becomes -7 and 5. -7 and 5, and this point is 4 and 2, so that becomes -4 and 2. So another thing is -4 and 2, that's the one point. The mirror image of this -4 +6 is +4 +6. So now it looks exact, right? Okay, recheck. Yes, correct. So I was just missing this one. If you look at here, instead of taking 7, I was taking 6. That was my mistake. Okay, go to number 28. You have functions. You just have to find out sum, difference, and multiplication. Just add them and simplify. 2x plus x becomes 3x plus 5. Next one, just subtract h from z. X minus 2x is -x. 3 minus 2 is +1. And multiplication at 3. So just multiply these two and replace x by 3, or just put 3 and then multiply. It doesn't matter. 3 plus 3 is 6. 3 times 2 is 6 plus 2 is 8. 8 times 6 is 48. So multiply these two functions and put x equal to 3. That will be 48. Okay, let's go to the next problem. 29. I already spent 1 hour and 30 minutes already, so let's keep working. We are trying to divide h by z, but we want to replace x by 2. So you can just replace x by 2 and calculate first and divide. You can do that. 2 plus 4 is 6. 2 minus 1 is 1. So 6 times 1 is 6 on the top. 2 times 2 is 4 plus 7 is 11. 6 over 11. Okay, value that are not in the domain of z over h or h over z, so which makes this g of x function 0. So you need to solve g of x equals 0. So this is for problem 29. For this function, you don't want to make g of x 0, so solve this and try to see what value of x makes g of x 0. So if you just divide both sides by 2, x equal -7 over 2 makes this function on the denominator 0. So the domain is, the value that are not in the domain is -7 over 2. So -7 over 2. Okay, Let's check. Okay, let's go to next problem. Problem 30. One more time, you need to find the multiplication, domain, minus, and domain. Multiplication, just multiply them. So this function goes on the top, this function goes on the bottom. So eventually it will be on the top there is 5x plus 3. Oh, this is just a multiplication. So 5x plus 3 times this 5x plus 3 over 2x squared um, plus 1. That's the function. And the domain of this function is the thing you have here on the denominator cannot be equal 0. Because this x squared is always either positive or 0, this cannot be equal to 0 for any x. So domain would be all real number. There is no actual restriction here. So you can just say from negative infinity to positive infinity. Just subtract this minus this. Just write it down as it is. And you can write, f is 1 over 2x squared and then plus 1 and minus g of x is the square root of 5x plus 3, and domain is the same thing as a domain of this. The restriction is coming from here as well, but actually there is no restriction because this value cannot be equal to 0 for any x. But we also have to consider this expression here now. So the value inside this radical sign cannot be negative, so you have to solve to find out the domain of this combined function, which is problem, let's say problem 30. So the domain has this restriction 5x plus 3 should be non-negative. So to find out this thing, just solve this inequality. So x should be greater or equal to negative 3 over 5. That's the domain of this f minus z, greater and equal to negative 3 over 5, comma, positive infinity, parentheses. So that's the domain. Okay, domain of the multiplication is not right, so let's check it one more time. Okay, I did the same mistake here. I forgot about this top part. There is a radical sign, so I have to consider the radical sign. The same thing will be true. This radical, inside the radical should be non-negative, so I need to do the same thing. This 5x plus 3 should be greater or equal to 0, so x should be greater or equal to negative 3 over 5. So I did the same mistake. I did the mistake here. I did not see, or I did not think about the top part. There is a radical sign. If there is a radical sign, then you have to think about the top part as well. If there is no radical, then you don't have to worry about the top part. You just have to worry about the bottom part. But this time there is a radical. So let's recheck it. And that's right. Let's go to next problem. We have given function f and g of x. We need to find out the it's the, let's see, is it, what is the symbol here? Okay, that's not multiplication, it's a composition. So this is the same kind of problem we already did. It's a composition. So look at the function f of x, plug, replace this x by g of x and simplify that. That will be 2x plus 1 minus 4. So that is 2x minus 3 on the top, 2x minus 2 on the bottom. So 2x minus 3 on the top, 2x minus 2 on the bottom. Okay, I just replace this x by g of x and plug the value of g of x. For the domain, you have to keep in mind that domain is a restriction. You have to see the restriction for g of x. There is no restriction for g of x. And now you have to see the restriction of this final product. As you can see on the bottom part, there is a restriction. This 2x minus 2 cannot be equal to 0. So 2x cannot be equal to 2, x cannot be equal to 1. So that means the restriction is the domain cannot have 1. So what you have to do is you have to use the from negative infinity up to 1, not including 1, and then where is the union sign? Union 1 to positive infinity. So this is the domain, all the real number except 1. That's right. Let's go to problem 32. You have graph of, this is also, again, I see that this is more practice for you guys. I already did this thing. Absolute value of x. You are shifting the graph to the right because here is a subtraction, and down 3 unit. To the right 4 unit, and down 3 unit. 1, 2, 3 unit. So this goes here and 3 unit. Yes, to the right 4 unit because there is a minus 4, so you have to take it to the 4 unit right, and minus 3, so down 3 unit. Check it. Great. And the last question, we need to find out either it's even or odd function. We have to use the same idea. We have to if you think about, this is square root function, square root of x function. So this is neither actually, because to be the even function, the graph should be symmetric with respect to y-axis. To be odd function, graph should be symmetric with respect to origin, but this is not the case here. This is if you see here, this is 1 over x cubed. This is cubic function, so this is odd function. Here I need to replace x by negative x, and I need to check it. Literally I need to check it. You can use the same trick to the f of x and g of x, but I did not do that because they are very simple. So I'm going to do the last one. Okay, 33. I'm going to find out h of negative x, which is negative x square, absolute value of negative x, positive 8. This is just x square, absolute value of negative x is again absolute value of x. So as you can see that this is the same function as f x. So h of negative x is same function as f x. So that means it's the definition of the even function. So let's check it. Correct. And we're done. So that's the 33 questions. I hope you know you could learn from this video and you do more practice. Okay, all the best.